G'day everybody, Nick Dingle back with the part 2 of our programming fundamentals topic. And in this one, we're going to start having a look at some of the theory that goes into developing software. Because one of the biggest things is a lot of people think that when you're developing software, you jump into Visual Studio Code, you hack out 1,000 lines of code, and there's your software, and you can sell it for $1 million. While that does happen, there are instances of people who can just jump into code and just build things. If you're working for a company, there's a good chance that that will never, ever happen. There is a process, there is a flow, or what you call an approach to which you actually have to develop the software. You have to plan it first, you have to design it, and then you actually make it, test it, and give it to the people. It's not just this make it, give. That doesn't happen because then you end up with buggy software, with incomplete features that the client probably doesn't even want. And I'll talk about who a client is very, very soon. So we're going to focus on the approaches in this particular video. And the next one, we're going to look at some of the different diagrams that you're going to utilize to design your software. Now, I've already sort of gone through this, but realistically, it's a team of people that work to develop a software application. Okay, it's not just a singular code monkey mashing the keyboard. There's often multiple people. There are business analysts, there are creative designers, and there are all sorts of other people involved as well. But just quickly, some terminology for you all, because there's going to be a few I throw at you that may not make sense otherwise. So the first one is the developer. So they are the people who are developing the software, not necessarily coding it, but they're involved in planning it, they're involved in talking to the client, those kind of things as well. Now, who the hell is this client? I keep mentioning the client is a person or business in which we're going to develop this software for. So it could literally be someone down the road that owns a flower shop that comes and visits us and says, hey, I want something where people can buy my flowers. Or it could be an entire mining company that approaches you and says, hey, we need something to manage our WHS. Okay, and that would be an entire company you're working with, not just a singular individual. The next one is a problem. So a problem is something that can be solved using software, such as wanting people to buy flowers online or managing WHS problems at a mine. And the solution is the software and the hardware we develop for them that will solve the client's problem. Okay, so that would that would be the app, that would be the thing that we produce. That's called a solution. And the last one is approach, is the steps a developer takes in order to develop that solution. All right, so with that out of the way, let's jump into our first approach. And the first approach is a bit of an old school one, but it's fairly straightforward. It's linear in approach, and it's called the waterfall approach, also known as the structured approach. Now, I'm going to quickly grab my head and move me along. As you can see here, we have got a set number of steps to develop our solution for our client, and we start at the top and we work our way down one step at a time, ensuring that each step has been completed before we move on to the next one. So it's a very linear, it's a very trudging, it's a very slow, discrete approach to developing the software. And to quickly go through what these steps are, because they're going to appear again when we talk about the other approach. The requirements definition is where you sit down with the client and you say, okay, what do you want? What is your situation? Who are you? Those kind of things. You're getting like the base ground information so you can share that with the rest of your team. The specifications are things like, what does the software actually need to do? What does it have to run on? What are the really specific things that the client needs? Okay, that the client may not even be able to communicate with you, because they might say, oh, I want it to run on a mobile, but they might not be able to tell you if that's iOS or Android or what version, or if they're using tablets or mobiles, all those kind of things. Then the design is literally we sit down and we sketch out, okay, what is it going to look like? Where are we going to store our data? How is it actually going to behave under the interface for our user? Then we go, all right, coders, go develop this. This is where you hand over all that documentation. You say, it has to look like this. It has to behave like this. This is what we want. Next one, integration, is if you've got multiple parts that you need to piece together. That's what integration means, you integrate it together. Testing and debugging is just that. You're checking for bugs and you're fixing those major problems. You install it by giving it to the client and you help them set it up and you train them in how to use it. And then finally, for maintenance, you start patching, fixing bugs, adding new features. And in effect, when you get to the maintenance, you almost start again and you almost go back down through the waterfall down to maintenance because you plan some new features and you start, creating those and designing those and then delivering those. Okay. So with this approach, essentially as it sounds, it's very, very rigid. You have people working on the plans and communicating with the client up here at the beginning. And then as soon as we get into these two phases, you effectively have locked in the developers. You're not talking to the client as much. Let's just get the job done. And then the client comes back in with the installation when it's all finished and all beautiful and polished and ready to go. And finally, we start looking after it for the clients. You say, hey, give us $100,000 and we'll keep looking after your software every year, those kind of things. Okay, so to skip forward, the goods and the bads. Let's get my head back over here. So the goods are when you finished that approach, you've got a stable bit of software that the client 100% can use. It solves their problem. It works really well. Hopefully it's performant. In other words, it's fast as it can be. And it's exactly what you promised the client in the first place because everyone's following those stringent outlines and designs and all of that kind of stuff. It's a really polished application. Polished meaning, there's no rough edges. There's fewer bugs. You can never promise no bugs, but there's fewer bugs because it's been really, really tested and the client should hopefully love it. Now the issues, it is obviously slow, okay? Because you got to go through those stages and there's often only a couple of people working on the specifications and the designs, you're sort of stuck. Until those people are done, you can't move forward with your project. The developers are sitting around scratching their heads or working on older projects or maybe training themselves while that new bit of software is being planned. The other thing is it's not as flexible. So I was thinking of the wording for this one. It's not very flexible in terms of what if something changes mid-development? Okay, what if we planned out this WH&S program for the mining company, but then all of a sudden the laws change? Okay, and there's new requirements. Well, we either have to figure out how those new requirements are going to fit in, or we have to start from scratch. Okay, we have to start from the beginning and go, oh crap, it's thrown a spanner in the works. This happened many, many years ago before you guys were probably born, but with GST in Australia. So before that, Australia had taxes on different food items, different electronic items, but the problem was all the taxes were different on those items. So the Australian government decided, all right, GST, goods and services tax, it's going to be a flat 10%. No one else pays any more. You can pay less if it's fresh fruit and a couple of other things, but otherwise 10%. Okay, and that kept it really, really simple. But the problem is software that was already out there that handled those taxes now had to scrap all of that and introduce GST. That was a huge undertaking for accounts, for a point of sales, all those kind of things. So Waterfall sucks when it comes to those kind of things coming in. Now, I haven't mentioned it yet, but sometimes this is called the structured approach or the waterfall approach. It means the exact same thing. Now, the other thing I really always like to do is come up with a bit of a sentence to sort of, for each word, so D, S, D, D, I, T, I, M, I still have not come up with a decent sentence. Like some old hags can't always hide their old age, so katoa. If you don't know those, then maybe you're not old enough or you didn't listen in maths. Please, if you can come up with one, I'd love to hear it. Now, what are you going to make with the structured approach? You are going to make things that are big, cost a lot of money, that need time, that need lots of testing. These are things like bank software, video games, surprisingly enough. They go through the waterfall approach because all aspects of the games need to be planned before it's given off to the modelers and the coders and the level designers and all that. Management software for managing, whole corporations and their workers and their resources and their stock and all that kind of stuff. And point of sale, if you work at Macca's and you've ever used the point of sales or you've seen it change, that software would have gone through a very rigorous set of steps to make sure it works properly and that it's good for the user when it comes to them. Okay, so that's the waterfall approach. Pretty straightforward. You got your set steps of the requirements, the specifications, the design, the development, integration, testing, installation, maintenance. a lot of steps to remember. So I'd love to come up with a sentence. And if I do, I'll put it on the description of the video. Our other approach, we've got an agile approach. And as the name sounds, it's a lot more, it's quicker, okay? And it's a lot more flexible, and it goes through loops of development as opposed to the structured sort of step 1, step 2, step 3. This one, while it does have the same steps as you can see, we've still got requirements and specs and design and development and integration and testing and installation and maintenance. But as you can see, it constantly is moving. And there's 2 arrows in the middle to sort of represent that there is sometimes multiple loops going at the exact same time. So there's multiple teams working on it. So what this is, it's an iterative approach. The idea that you start with the first most important feature of your application, you develop that first, and then you move on to the second feature and you develop that second, and then third, and then fourth. And you're actually doing this entire loop every single feature. So that's what I mean by iterative. It's like evolutionary. It evolves from something simple to bigger and bigger and bigger. And every time we work on it, it adds another feature and grows, and adds another feature and grows. So for example, if you're creating a brand new social media platform, let's say, you might first of all add in the ability to add friends and send messages. That might be the only thing that this program is able to do when you first begin. And so you would go through this loop and finish that feature. And then once it's done, you can release that feature to the public and they go, oh, it's really simple. I want more features. Well, by the time people even whinge that they want more features, you can start adding on the next feature of being able to follow people, then adding in stories and all that kind of stuff. You're just adding in more and more features. And the great thing is, it doesn't even have to be one team waiting around for the first feature to finish to work on the second feature. The first team can be working on the core features, while the second team can be working on those stories and those brand new features, while the first team is still going, so that when these guys finish, these guys are almost ready to release. And that means the first team can move on to the next feature. And you might even have a team 3 that's working on something else in the background. And so again, this loop just continues and continues until we have a functioning, maybe incomplete, working solution. So it's faster, it's more flexible, more features can be added over time. Okay, those kind of things sort of kick into gear. Sorry, guys. So the goods and the bads. So the goods are pretty straightforward. It's quicker, it is cheaper, and it enables multiple features to be worked on at the exact same time. Those are the core features. One of the other big features is because we are constantly got these working versions, they arrive really quickly to the user. They can give us feedback and we can release it straight away. So it's a quicker sort of release time, but also development time in that sense. And it also is a lot more flexible. So if things like GST or new WHS laws come into place, they can react to those features and they go, oh crap, feature number 2 is not going to work, scrap it, let's build a new feature instead that's going to adhere to these new laws, those kind of things. Now, the negativity is that because you obviously have multiple teams working on multiple features and you're trying to sort of fit those together, sometimes the jigsaw pieces just don't fit and you have to get a pair of scissors, cut those jigsaw pieces into the right shape and sort of sticky tape them up. So it can be buggy, it can be a little bit inefficient, and it can sometimes just not work, okay? It is often more suited to smaller resource teams or sort of medium-sized teams. Large teams often want to work in sort of a very structured, this is what you have to do approach, whereas smaller teams can sort of, knee-jerk respond to things. And the last one is scope creep. Scope creep is the idea that somebody comes up with an idea and someone else comes up with an idea. Oh, that's a good idea. We should add in a blue Windows. And then let's add in some more buttons. Or we should be able to print things. We can create reports. And then all these extra features get added into the program and people start thinking about more and more and more and more and more and more. And the idea of this application or solution becomes so big, it's completely unmanageable and it never gets finished. And this happens with smaller video games quite often, where indie developers go, wouldn't this be cool? We can make an RPG game where you can make your own items. But what about, Tears of the Kingdom where you can strap multiple weapons together, but then you can add in like enhancements where one of them's on fire and one's an electric on, but then you can dual handle them. And then, things become so bloated and so big and so massive you can't undertake it. You can't build it. All right, so but what are you going to make using the Agile approach? There's lots, there is tons, but I've kept it simple. Social media apps are a great example because they're constantly evolving. They're constantly adding new features as the program sort of, becomes more mature is the word I'm looking for. Smaller video games or medium video games, this is great for because you can have a solid base for a video game, release it to the public as maybe an early access or even a finished live service game. And people say, oh, but I really want this feature. And the developers can add in those extra features and all those kind of things. And then finally, mobile apps. Same to the video games. Often you see mobile apps get released. And over time, as they become more successful, they continually add more features onto the app. Okay, so I'm going to leave you with 2 quick questions. Okay, I love the fact that the question marks are above my head spewing out. I brought these scenarios up, but I want you guys to actually sit down and have a think about these different approaches, how they apply in the real world. So you've got a large mining company, and they want you to develop a WHS or a work health and safety application to manage their employees. It has much government legislation to protect the worker safety. The workers log their hours, their breaks taken, those kind of things. It's a large budget, and the software development company have been employed to manage the production of the software from beginning to end. What is the suitability of the structured or waterfall approach for this project? And I want you to give me the goods and the bads of those ones. So have a go, write down the scenario, and write down the justification for why you would use the structured or waterfall approach. Give it a pause, and let's go to the next one. Quick one, a flower shop. A new shop called Fun with Flowers has opened up in your town, and they wish to create an online catalogue where users can browse and purchase their flowers. Along with bouquets of flowers, they can also add custom notes to their orders. So discuss the suitability of the Agile approach, again, considering the advantages and disadvantages and why the waterfall is not appropriate for this one. Again, write it down, come up with the goods and the bads. All right, guys, thank you very much for watching. I'll catch you in the next video. See you then.